The OmniScan MX2 position C scan is typically associated with corrosion mapping or composite type inspections with a 1D linear array probe at 0 degrees. The C scan is available under the display submenu for any of the layouts that contain a C. Those same layouts are also available by right-clicking on the title bar and selecting from the same list. The 0 degree 1D linear array probe inspection can be seen under the focal law, and we can see that the C-scan was acquired with a linear at 0 degree. This is a phased array mode with specific benefits for corrosion mapping and linear scans. The aperture was a 4-element aperture using the entire probe from 1 to 60. So our focal law number 1 on the edge of the probe using elements 1 through 4 generates the A scan at virtual probe aperture 1, and the entire probe was used all the way over to focal law last. The beam was at 0 degrees with a 6-degree focal depth, and auto program was used. So this axis on the position C scan is in actual millimeters. Again, that's another distinction between the typical sector scan type where we get focal laws on the vertical axis. The 0 degree at linear allows a real volume C scan that allows millimeters on the vertical axis, and then the horizontal axis represents the probe or scanner movement through the component. So under our scan area for the C scan, the operator entered a scan area of 0 millimeters for the start, 400 millimeters for the end, and we're taking the data at a resolution of 0.5 millimeters. So every 0.5 millimeters of probe or scanner travel, the C scan is generated for every A scan gets an independent pixel. Under the C scan display, with the AS and C scan selected, our view settings C scan allow us to select the source of the A scan. For a sector scan pulse echo weld inspection, that source would typically be the amplitude of the signal in gate A. We're taking a thickness reading now for corrosion mapping or for composite inspection, and this thickness reading is based on the thickness in gate A based on the reading that we have selected here. Whether we're using the hydroform or Rexorform or some other type of probe, the thickness reading is a function of the gate logic of either the signal in gate A, the signal of gate A minus gate I, or for instance in a thickness type of reading on a paint coating, we can take 2 gates and subtract one from the other. The resulting reading is directly related to what thickness mode we're in. The thickness is also determined for a range. On the C scan, we'll see 2 vertical bars, one describing the color palette and one describing the range for expected values associated with this. So in this inspection, the operator entered a thickness reading, a thickness range of 2 to 15 millimeters, which would eliminate any readings outside that range from appearing in our statistics. Under the display properties for the color palette, We are now in a depth color scale, and this scale will extend from 5 millimeters to 14 millimeters. To find the lowest thickness, we would typically take the color palette and reduce the readings until we see our first red pixels appear. Readings associated with the C-scan for corrosion mapping or color palette. Under measurement, reading, we have predefined lists associated with corrosion or immersion, and these will give us the typical readings used with thickness inspection, enabling our gates or enabling our cursors and creating a box using the cursor, the red cursor and the green cursor. We will create an area relative to the zone readings. Anywhere we see a T-min zone, within our boxed area, we see the thinnest reading in that boxed area and the position on the scan axis and index axis of that reading. We'll also see material loss based on the thickness that was entered for the part. The cursors can be turned off under the display overlay cursor. So as we move our data cursor through the component, in this axis is the mechanical movement of the probe. Here we see the pipe to wedge interface. If this were hydroform, this would be the water column to pipe interface. And we can see that we have a near surface resolution of about 1.5 millimeters to 2 millimeters, depending on the surface condition, the frequency of probe, our coupling. That should vary between 1 and 3 millimeters. On this side of the probe, we see the A scan generated by elements 1 through 4. And on the other side of the probe, we see the last focal law generated by element 157 to 60. So as I move the probe or scroll through the data on the scan axis, we'll first see the bottom of the component, and we can see, or the back wall, and we can see that gate A has been placed over the area of interest to include the back wall. As the scanner or the data cursor is moving into areas of corrosion, we can start to see the river bottom of the component, and we can see the various deformation of the corrosion. Here we'll see a typical indication of a 1 millimeter flat bottomed hole. At a depth of 6 millimeters. Here we have an area of more severe corrosion where we're seeing multiple back walls. And at any position, the operator can define the river bottom or the low area of the pipe with the ultrasound cursor. These gate positions can be changed in analysis mode along with the thickness mode that resulted in our readings.